So part A, we actually had done in the notes before. I'm wanting the expected value of this random variable x. That's the same thing as the mean of that random variable. And if it's just a generic probability distribution, it's every x value times the probability that it occurs. So this is already in our notes when we started lesson, I believe lesson 4. So it's negative 5 cents, which means plays many games, they're going to be losing about 5 cents on average. So then it says, would the player be better off playing one game roulette on a $2 bet with a $2 bet on red, or playing 2 games and betting 1 on red each time? So basically I want you to compare, I'll call this one Y, where you're just going to do this random thing, actually, this random thing, man, I can read. You're doubling what's happening, or whether you should do that random thing 2 times in a row. That's what I'm supposed to be writing. It does reference the standard deviation. I will just go ahead and note that the standard deviation of x is 0.99. I probably should have told you that. It's the square root, the sum of the differences, whatever. I'm not going to go through that. That's what our standard deviation is. So our rule is, with linear transformations, go ahead and do exactly every transformation to your mean, which means if I'm doubling it, I'm just going to double my original mean. So 2 times negative 0.05 means now I should expect to lose 10 cents after many games on average. Your standard deviation doesn't get added or subtracted. Our rule was you can multiply. That's supposed to be an x. That doesn't look like an x. So I'm just going to take 2 times the standard deviation of x, which is that number I just told you, 0.999. So 1.998-ish. Now, if I instead think of this as a combination of random variables, the average, you are allowed to add means. So I'm going to take the mean of x and add it to itself, which means I'm taking negative 5 cents and adding it to itself. I'm still getting an average loss of 10 cents over time. However, your standard deviation will not be the same because you cannot add standard deviations. You have to add the variances and square root that sum. So add your variances, sigma squared x plus sigma squared x, and then square root that result. So probably should have told you earlier, when I had calculated this, I actually got 0.997. So I'm just going to use that. I could just say 0.99 squared again, but 0.997 plus 0.997. So I'm taking the square root. I didn't even write that down. The square root of that sum turns out to be 1.412. So the loss is pretty much the same. Both versions have an expected loss of 10 cents. However, the variability of playing 2 games is smaller than doubling 1 game. This variability is smaller than that variability. So it means there's less of a risk of a large loss for that player, but there's also less of a chance of a higher payout. So I'm going to get that written up. You'll see it on the answer key version of the notes if you want to go check my explanation.